Good morning, class. Today we're going to learn about transformations, and we're specifically going to look at the transformations of the absolute value function, which will be our first function in Algebra 2 this year. All right, so y equals x is y equals absolute value of x. This is our absolute value function. These bars means absolute value, which means anything between them results in a positive answer. And as you can see on the graph, the shape of it is all in the positive direction of the y values. So that your output there's going to be all positive numbers. We're going to describe our different transformations and how it changes the graph, how it changes our equation, and then the domain and range. So it's going to be very observational and detail oriented. All right, so y equals the absolute value of x. Okay, this description here is the parent function. All right, the domain is the x-axis from left to right. As you can see, if you keep pulling it down, it's going to grow to the left forever, but also go to the right forever. Okay, so this is going to be all grown numbers in the domain. So in this one, it's going to be parentheses and then negative. I use INF for infinity because it doesn't give me an infinity symbol. The special characters aren't allowed in the notes here, but INF means infinity. And infinity to positive infinity. All right. And then our range is from, if you look at your y-axis, is bottom to top. There's no function down here at all, so there's going to be no negative numbers. But at the top, we have 0 to infinity. As you can see, it keeps on growing and growing. All right, so the range here would be bracket from 0, comma, infinity, in positive direction. All right, so there is our range. Okay, notice on this parent function that you can divide it exactly in half only through the y-axis. So it has a line of symmetry on the y-axis of this function. No other diagonal lines or horizontal lines will cut the function in half. Okay, so let's look at our first transformation. Here we have the absolute value of x plus 2. All right, and you look at our parent function, basically adding a 2 to it. All right, so when I show this graph, I click in the circle here. And by the way, there's a digital version of the notes in your folders, which you can also come in here and change things and play with it just to see how your absolute value changes. So what I'm going to do is I'm going to leave this parent function one on and in red. And then as we add a new graph to it, we can see how it changes from our parent function in red. So as you can see, here's the green graph, it's plus 2. Well, what happened? The graph simply moved up 2 units. All right, let me see if I can get this to zoom out more. So now you can see 1, if you count up, 1, 2 units. Every point on here is moved up 2 units. All right, so how did this thing change? Well, it translated up 2 whole units. All right, so that's the description. Okay, that's what happened with this transformation. We added a 2 to it, it translated up. So now let's look at the domain. As you can see, it still grows left and right forever. It's going to cover all the x-axis. So our domain will be the same as here. I'll just type it in again. All right, so we have here negative infinity to positive infinity, just like so. The domain didn't change. Our range. All right, again, so since it moved up 2, if you look at the range for the green graph here, it's now going to start at 2. All right, so we're going to have to use the bracket 2 all the way to infinity. All right, so there's the description. We translated up to units. We added a 2 to the parent function. Domain's infinite didn't change, negative infinity, positive infinity, and the range is from 2 to infinity on the y-axis. Again, bottom to top, guys. All right, so let's turn this graph off, parent function, and let's do something else to it. Let's subtract 5 from our parent function, the absolute value of x. All right, let's show that one. And it moved down 5 units. You can see, count it, 1, 2, 3, 4, and 5. All right, so subtracting from this absolute value parent function moves the function down 5. So that's what we're going to right here. So I guess the word would be translate. 5 units. All right. Okay, so this is good. Our domain still grows left to right, so it's going to be the same thing. So negative infinity to positive infinity. All right, our range, okay, this time it starts at -5 and goes up forever. So -5 to infinity. So bracket, -5, and then to infinity, and then close the parentheses. All right. Very nice there. Okay, let's turn that one off. Let's move to our next thing. So look at the difference here, especially compared to adding 2 here. Here, we're subtracting 4 inside the absolute value bars. What do you think is going to happen? Well, let's see. Turn it on by pressing this circle here. And as you can see, it moved over to the right 4 units. 1, 2, 3, 4. Okay, so let's write that description in. Translates right 4 units. All right, there we go. Translates right 4 units. Here it said subtract, but it moved to the right. So, you know, positive numbers are on the right, negative numbers are on the left. That's interesting. I want you to make note of that because this is the part that most students miss on every parent function we go through this. And we do this for every parent function. So in your next lesson, we're going to see why this happens, okay? But just kind of think opposite for now. So if it's inside the absolute value bars, it's going to go right rather than left. Okay, so kind of think opposite there for now until you understand what is going to happen there. Okay, so let's look at the domain. Okay, the domain didn't change, still opens all the way left and all the way right. So we got negative infinity to positive infinity. All right, our range, again, on top, the range didn't change either. Since it just moved to the right, it's still from 0 in y numbers, okay, 0 to infinity for the green graph as well. So bracket 0 to infinity. All right, so remember, infinities always get parentheses. 0 is a bracket because it's included on there. All right, there's no asymptote through there. There's no open point there. The function itself isn't made with a dashed line, so we're good to go. Okay, let's turn this one off. And this time we're going to add 3 inside the absolute value bars. Okay, now what do you think is going to happen? If we subtracted 4 in the previous one and went right 4, what do you think adding a number to the x inside the absolute value function is going to do? Well, if you guessed move left 3, you're correct. Let's see. Boom, there it is. -1, -2, -3 to the left. All right, so translates left 3 units. There we go. All right, so the domain, again, didn't change. Left negative infinity, positive infinity. All right, and then our range is going to be from 0 to infinity again. So bracket through the 0 to infinity. There we go. All right, trucking along now. Okay, so let's go ahead and turn this graph off. Okay, I've got our parent function there. And here we have a negative, basically it's a -1 multiplied in front of the absolute value bars. All right, so what's going to happen? What do we know about negatives? Okay, well, what we do know about negatives is that they make things opposite. So when I turn this on, bam, what's going to happen? It's like a mirror reflection here. All right, everything shifted downward. All right, so what happened? It reflected about the x-axis here. So we say reflection about the x-axis. All right, so let's look at this domain. So even though now it's opening downward in orange here, It still goes to the left forever, still goes to the right forever, so the domain didn't change either way. So parentheses, negative infinity to positive infinity, and close. And there we go. But the range did change. So now with this orange one, there are no positive numbers. Okay, it's now going only negative numbers. So our range did change. So again, remember, range is bottom to top. A lot of times what happens is students will write this backwards. Okay, so bottom to top, what's all the way to the bottom, as you can see, it keeps going down, down, and down. It's negative infinity all the way to 0. All right, so let's type that in. So parentheses, infinity is always good. Parentheses, negative infinity, comma to 0, and we'll include that with the bracket. And that is the correct range here. Okay, so let's turn that off. Let's kind of center this parent function here. And like I said, you're going to have an interactive graph. You're basically going to have this as a blank version, and you can play around with this all you want in your notes. Okay, so here we are multiplying a half to it, a fraction. Okay. And when we multiply a fraction to it, let's see what happens. Oh, that's kind of interesting. Didn't move anywhere. It's still at the origin, but it's much wider. Okay. So this is like if we took the y-axis and crushed it vertically, and we call this a vertical compression. Okay, and in geometry, this is basically a dilation. Okay, so it's been vertically compressed, and it has to be by a factor. Remember, you went through scale factors in geometry. By a factor of, and that's a multiple 1/2. All right, or you could say 0.5. All right, so a vertical compression is that. So kind of a note on that is you'll get that in the next lesson on where those bounds for compressions are. So if it's a fraction there, that's going to compress it and vertically, which makes it widen out. Okay, let's look at the domain. Okay, well, still goes to the left forever and to the right forever, so that's still going to be negative infinity, positive infinity. All right, and the range, even though it's wider, it still goes forever. It just kind of opens out wider faster. So from 0 to infinity still. So bracket, not a brace, bracket, 0 to infinity. All right, so there's that there. Okay, let's turn this one off. Now, this time we're going to multiply our absolute value function in the front by 3. All right, so if we multiply by a fraction, it widened out, it compressed. What do you think is going to happen if we multiply by 3 in the front? Well, let's check it out. Boom. Much skinnier, okay? This is like taking the y-axis and stretching it vertically by a factor of 3. And that's what this is going to be called. It's going to be a vertical stretch. By a factor of 3. Okay, so vertical stretch. Also, probably should have noted that we use the abbreviation VS, or I do at least, for vertical stretch. For vertical compression, you guessed it, VC. Okay, so I'm going to notate that. All right, so let's look at both of them together. All right, so compression and stretch, and see how that function changes. All right, let's go on to the domain of this vertical stretch. All right, so I'm going to turn it back on. So the domain is still the same, even though it's much narrow, it's opening out much slower than the parent function, but it's still going to go forever to the left and to the right, still goes. So this is going to be negative infinity, positive infinity again. All right, and then our range, okay, so it starts at 0, stretches, starts at 0, and goes to all the numbers in the positive direction of the y-axis. So brackets 0 to infinity and parentheses. All right, so those are the basic transformations we're going to cover here in Algebra 2. And here it is applied to our first function. Next lesson will be how these changes apply to all the parent functions we've learned last week, and get more into depth of the vertical stretch and compression to see why those are, and what's going on here when you add and subtract a number inside the absolute value bars. Why are they going opposite directions? Okay. Alrighty, guys. Have a great day.